Okay, Gimela. Generally, so today I'll be taking you through three topics. Ke boletse gore often ra gona re leka gore ga re revise re ne re tsa topic tse di tsamaisang jang re di dira tsotlhe at the same time. So this time around we are going to discuss the reactivity series, extraction of metals, the electrolysis of aqueous compounds. All these three topics they have something in common. The reactivity series. So level one, reactivity series on its own is a topic. You have to memorize the reactivity series. So bana sekolo ba rata go nna ba tshega ba bolela gore nna ke le ngwana sekolo ne ke memorize reactivity series ke re poso kama azi le khosi gopla. Ha ke re poso kama e nna e kate poso ke motho o fana ka kama the most popular saying in Botswana, Kama, also Kama, Azi. So for now it helped because the Ghana like if you don't with the Uzi. So the change like get Azi. Azi le Kosi. So I go to Sahaba because I had a friend who don't with the Kosi. Then I got an Hopla. Poso Kama Azi le Kosi Hopla. How can you declare Magazine perfect? Then you have to, it's a mnemonic, right? You have to know what a mnemonic is level. Poso ke potassium, so ke sodium, Ka ke calcium, Ma ke magnesium, A ke aluminum, Z ke zinc, I ke iron, lead ke lead, Co ke copper, C ke silver, Go gold, platinum. So ke di-claim ka tse lentseng ya lalo. It's a topic on its own. One source to grammar reactivity series. Wa go itse gore the main thing that you should know ke gore reactivity increases as you go up. Reactivity increases as you go up. Meaning gore tse di go godimo they are more reactive than tse di go tlase. So how is that important to make them? Baka go botsa gone gore between calcium and magnesium which one is most reactive. Wa go tlo ke go godimo calcium. Between sodium and magnesium, which one is the least reactive? It's magnesium. Here got us right. Yeah. So putting when the substitution reactions. Substitution reaction. But I hanga or I get if you have calcium oxide plus sodium products are if you react calcium oxide with sodium or as the reactants, what will be the product? Well, we told and melanka is this reaction possible? Sodium yes, go with demo more reactivity is above calcium, so it will be able to displace because it is more reactive than calcium. It will be able to displace calcium of the oxygen. So finally, sodium oxide plus calcium. How say you want to potassium oxide, then you add magnesium. What will be the product? When I lay potassium oxide, then you add magnesium. What will be the product? There will be no chemical reaction because calcium, again, potassium is more reactive than magnesium. So magnesium won't be able to displace or substitute oxygen on the will be unable to substitute potassium from the oxide. So that reaction will be impossible. So that's how you use the reactivity series. The other way, some reactions, like one famous process, there's one process that you call galvanization. Galvanization, because co-industry, industries which produce iron or iron products, but not very stressed, but this challenge, iron, it easily rust. How some will iron go finance ka boturu ya rusa. So le ka bojotlhe gore iron ya gago o e fokotse go rusa, right? One way ha rena di corrugated ions mo le reng ke disenke go di tsa go di ska di rusa di protecta ka zinc. Maybe that's why but why di zinc because they've been coated with zinc. That process of coating corrugated iron with zinc, galvanization. It is just a way of sacrificially sacrificing actually uh, zinc so that it oxidized instead of iron. So it is the sacrificial protection of iron using zinc. So ka bona ha hore zinc e go godimo ga iron, zinc e go godimo ga iron in the reactivity series. So gore la hore it is more reactive than iron. So how oxygen e tla e re ile tele mthako fa how oxygen e tla oxygen ha e tla e re ile tele iron to form rust. Oxygen will be taken by this guy. Instead of oxygen causing rust, it will be taken by zinc. I mean from a zinc oxide. And luckily, zinc oxide have for me rose. So that way you have sacrificed zinc to protect iron. And then the zinc has rose. How about the zinc rose? So you for the first 10 years. For the first couple of years, this guy had enough rules. So that's how you are going to use your reactivity series. Then the other topic in which you find reactivity series applicable is extraction of metals. What topic in your extraction of metals? You are expected to know two things. You are expected to know your ores. You have to master your ores, and then you have to master the methods of extraction. Yeah. So, no one told me this, right? Because I'm trying to make the job easy for you guys. No one told me this. I go school. Hage bala go school. No the notes. Teacher extraction of zinc. If you go about the extraction of iron a little bit. If you go iron right? And the extraction of tin. Blah 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 note. Extraction of lead. The extraction of calcium. Who do you know extraction of magnesium? Extraction of sodium. You know so right? Even difficult to memorize. By the time most of you know you're forgetting everything. But now you can think about I begin a house of one. So level line. Like how you have to understand your ores. So you can think about already the first four elements the ores are chlorides. So so from all these guys here, the ores are chlorides. So the ores are chlorides. Mo exam ya ka mpotsa gore potassium is from potassium chloride. Sodium is from potassium chloride. Calcium is from calcium chloride. Magnesium is from magnesium chloride. We are finished. Nothing. How many we tell how to be notes? Ores are chlorides. Then aluminum. We fell how lead. The ores are oxides. Well, the ores are oxides. So the ores are oxide. We feel it. How to get the notes? How aluminum oxide. Zinc is zinc oxide. Iron is iron oxide. Tin is tin oxide. Lead is from lead oxide. We feel it. Just that those oxides will be having impurities in addition. And most of all, there will be some also be given special names like aluminum. Then we will take bauxite. So aluminum will take bauxite. It's aluminum oxide plus impurities. Iron, for example. Iron, debate. Go na le ba reng ke hematite le magnetite ke di oxides. So iron go na le hematite yone batho ba re ke magnetite. So they're basically oxides. So you can take a minute la ka tsena mo Google wa check gore formula ya magnetite ke mang, formula ya hematite ke mang. So that we learn extra. How can we do the oxides? I will let a bit further. But I don't know what is hydrogen le carbon yo tse di seng di-metal just for discussion ha ntse ntse jalo. So ha tlasenyana go na le copper le silver. So for your syllabus, I will about the ores that's one. But just for knowledge's sake, here, what I usually the ores are usually sulfides, the sulfur compounds. So copper, for example, you want from oil, you think copper iron sulfide. So yeah, the ores are usually sulfides. The sulfides, the ores are sulfides. Silver, I want from silver sulfide. Oil, silver sulfide. Copper, one from copper iron sulfide. So what I'm out of the arrange that thing. The interplatinum the other zone. The other is the gold and the platinum that are found in the pure state. How on the or fail the Gakanyari ores, right? Then what like extraction. That one talk extraction in Mokafia. That be cool. So, kanya extraction mo for yani, you have to know you master your method of extraction. So, tla lema gore tse di go godimo tse this first four, I mean, original oxide when tse di fatshe from potassium to aluminum, they are extracted. They are extracted through electrolysis of molten ores. The difference in the top five one, they are extracted through electrolysis of molten ores through electrolysis of. So what is electrolysis of molten electrolyte. It's a very expensive process because you have to keep basically salts. You have to keep that also salts. So you have to keep those salts molten. So you're going to use a lot of heat, and also you're going to use a lot of electricity. It's a very expensive method of extraction. That's why you can never see these metals. The reduction of So it's 30 chloride plus oxide one. Then after 4, you have this block of oxides. So this block of oxides. So when it comes to extraction of these metals from the ores, they are usually or before get them what will go. This metal of aluminum to lower the melting point or iron. There is a certain compound they think going to cryolite. So what I'm saying, we do reduce our more thing going to cryolite. There's a cryolite. That was why to lower the melting point of bauxite so that you don't use a lot of heat energy. So the difference they are also are oxide. For you to extract them, but I want our carbon is higher on the reactivity series relative to these metals is higher. So carbon is more reactive. So we are going to use carbon to reduce these ores to the metals. We are going to use carbon. And I'll tell you one thing, this is not just the regular carbon, it is a specially prepared carbon. It is like a coke. So this carbon is a specially prepared form of carbon. It is like a coke. So usually we burn this carbon and insufficient oxygen to produce carbon dioxide, and it is the carbon dioxide that you are going to use to steal away the oxygen uh, from these metals. And then from those oxides, we remove the oxide part using the carbon monoxide. And then by so doing, that also be reduced to the metals. The fact that and that whole process in the furnaces, oil or heat and then you are going to end up with these metals: zinc, iron, tin, lead. These are all furnaces from reduction with a coke or carbon monoxide. So I have claiming for which what they use to reduce the metals, we use carbon or coke or carbon monoxide. Look for those answers: coke, carbon monoxide. Yeah. And then you have copper le silver. Copper le silver tse di hatsi, these metals tse pedi the metal tse di fa tse pedi copper le silver. How do you extract them from the sulfides ores? How do you extract them from the sulfide ores? Through electrolysis. But this time around, is a cheaper form of electrolysis. Electrolysis of aqueous compounds. So, copper and silver, we extract them through electrolysis. Through electrolysis. But this time around, it's electrolysis of aqueous electrolyte or aqueous ores. So this time around is electrolysis of aqueous electrolyte. Kwana nearly electrolysis of molten. So we have to use heat to keep the salt molten. Here you just have to take the sulfide or where you do then you apply electricity. Or then and then you start electrolyzing. Then you get your copper. Cathode. Very simple. Cathode. So that's how you extract these metals. Of course, gold and platinum, they are found in the pure state. So how much of that is so we use the same reactivity series to memorize extraction of metals. Then the last part, there is another topic electrolysis. Of course, electrolysis of molten compounds, but with electrolysis of aqueous compounds, you'll be having two ions migrating to the cathode. So ideally, which of the two cations will be preferentially discharged over the other? So you know what is the one? The answer is three. In three, all these other metals, they can never be produced. They can never be discharged at the cathode because they are all more reactive than carbon, more than hydrogen. Remember, in an aqueous solution, you always have hydrogen as one of the competitors, as one of the ions migrating to the cathode. So it's going to be hydrogen plus something else. So all these ions are more reactive than hydrogen. So what I use at the cathode, the more reactive ion has will prefer to stay in the solution. The less reactive one, it is the one that is discharged. Equal class same more reactivity system. You only discharge one. So hydrogen being below all this, so hydrogen will always be preferential discharged over all the salts. There will be only two cases in the exam. You are going to produce a metal at the cathode in the case of electrolysis of aqueous compounds. It's either a copper salt and a silver salt. A copper salt or silver salt because they are below hydrogen in the reactivity series. That's the only time I'll produce a copper, can I produce a silver. Otherwise, every time you're going to produce hydrogen. So, I want to really examine before examining it. How would the electrolysis of aqueous compound? There will be only three answers. It's either the answer is hydrogen or the answer is silver or answer is hydrogen. How can you point out answer is happen examine out of these three? When can I do it? I will do it. Yeah. Thank you so much for your attention. See you in the next session.